Hello, everybody. Welcome to day 14. We'll be talking about existential quantification. So we're going to dedicate the entire day to a new proposition. It's actually not that long of a file, as you can see from this listing on the right. We're really only going to do 4 videos. None of these should be that long. I'm hopeful that this sort of counterbalances the intensity of the induction day, which is a lot of new concepts. Here, we're really going to deal with only one new concept. The existential quantifier exists. So we've already met the universal quantifier for all, and it says, hey, for all x, for any x of type, this proposition holds. Exists is the dual, the mirror image of that. It says there is at least one thing of this type, such that this proposition holds. All right, let's see how it works in Coq. So here's a little lemma saying that there exists some natural number n, such that 4 is equal to n plus n. Now, math whizzes may have at this point identified that n is going to be 2. Metagame whizzes may have noticed that we say you can see the number 2 down in the proof there. So, okay. What's going on here? This exists says, look, there is in the world some natural number n such that 4 is equal to n plus n. What does a proof of that fact look like? Well, a proof here is going to look like a witness, right? Some number n that we're going to give to the reader saying, this is it. This is the number. And then some proof that says that our witness actually fulfills the proposition. So our proof is going to have 2 parts. First is going to be a part where we select a natural number n explicitly. We have to write some expression that's going to make it possible for us to show the second part, that the n we've selected when doubled is equal to 4. So as the prophecies foretold, 2 is the number that when doubled is equal to 4. 2 plus 2 equals 4. So the exist tactic is how you select a witness. Right? Exists is the opposite of intros. Intros says, oh, I have a for all here. Let me get that into my context and I'll work with this abstract value that's representing anything of that type. This goes the other way. Here, exist, and you give something very concrete. You give an expression that's going to get plugged in. Now here I've chosen a totally concrete expression, a number, right? S of O or whatever. But if we had stuff in our context, we could talk about that. You could put a function call here or something like that. We'll see that below. In any case, here we're selecting our witness. So what remains, if our witness n is going to be 2, notice our goal becomes just the proposition part, right? This part becomes our goal, and 2 gets plugged in for n. Okay, so now we've selected the witness. Now we have to prove the property. Okay, cool. So that's pretty easy. 4 equals 2 plus 2, that's just computation. A metaphor that I really like for these existential propositions is that of sort of like a package that gets shipped to you, right? A package has 2 parts, right? There's the box and you don't know what's in it, but then printed on the box is, say, a manifest that says, hey, here's the contents of the box. Or you can think of it like a present with a card on it. The existential, the witness, that's the contents of the present. And then the card or the manifest, that's telling you something about the present. So an existential is both of these things together. Okay. That's a simple example of how you prove an existential. How do you use one? Here's an example. So let's start out just following our noses. Wanted to get our context into good shape. For all natural numbers n, if there exists some n such that n is equal to 4 plus m, then there exists some o such that n is equal to 2 plus o. So they're asking us to solve this equation. N equals 4 plus m, n equals 2 plus o. Right, so we've got this set of 2 equations. And you might be able to see like, okay, well, just like grab 2 from here, add that to m, and that's a good candidate for o, right? These are just sort of 2 linear equations, and it's uniquely determined. Like, okay, that doesn't seem so bad. So intuitively what we want to say is like, okay, well, o is going to be 2 plus m. And then the math should just kind of work out. So let's try something. Exists 2 plus m. What? Sorry, wrong key. Exists 2 plus m. Let's get the error message out. The reference m was not found in the current environment. What do you mean? There's an m right here. What could you be talking about? Well, just as if you had a for all here, this is packaged up. So what do you do when you get a package? These days you wait a day or two maybe, let it sort of sit, and then you open it up. So we need to open up this package. We want to say, okay, look, I know H. H says that is a proof that there exists some natural number m such that n equals 4 plus m. Okay, let's open up the box and save the manifest, right? Give me the number m and the manifest that says what I know about m. So the way you do that is with destruct. So an exists has two parts. Here's the name of the thing inside the package. Here's the fact about the package. So if you then look at our context, we now have m up in the list of things we know about. And now we have hm, knowledge that n equals 4 plus m. So now this exist tactic will work. We simple. Well, that's maybe uglier. Let's, whatever. Apply hm. Okay. Now, as usual, this is just a destruct, right? Destruct, interestingly, is how we've broken apart every interesting proposition, right? We use destructs to work with and, we used it to work with or. I guess we didn't use it to work with this. We used intros to work with these two. Exists also gets broken apart with destruct. Now, so what that means is we didn't need a separate tactic here. We could have broken up, we could have opened the package immediately. Not exactly like a COVID pandemic mood, immediately opening your mail, though probably fine. But we can do it. Okay, and then at this point, now we can sort of walk through the proof exactly the same, right? We've just sort of, we never spend a moment with the package unopened. We just sort of carry out the rest of the proof. Okay, that's really all there is to know from a practical aspect of like, what do you do with existentials? There's an exists tactic, that's how you prove them. And then there's a destruct tactic that we already knew about for breaking them up into sort of their contents and the facts about their contents, right? Contents, facts about their contents. In the remaining videos, we'll see a case study of how you can use existentials, interestingly, to work with relating propositions and booleans, and then we'll do some like higher level discussion about like what's going on in Cox logic and how that relates to the rest of the world, because we're finally able to start to see some maybe some daylight between the logic that mathematicians do and the logic that we're doing here in Coq. All right, I'll see you on the next video.